Let's continue talking about the reactions of acyl derivatives, carboxylic acid and derivatives. Here we have an acid chloride and an anhydride. The reactions that they undergo are very similar. These are the two most reactive carboxylic acid derivatives in the series, the ones that we see for the most part. So acid chlorides here at the top. Then we have anhydrides. And after that, less reactive. So below in the reactivity would be esters and then amides. So I'm going to be doing now the reaction with Grignard reagents. And what I'm doing here for acid chlorides applies to the anhydrides. The only thing that's different is the leaving group. When we do a nucleophilic attack over to the acid chloride, and let's make it like general, the mechanism. If you have a nucleophile, this time I'll be talking in this video more Grignard. So let's say that I have another, let's say R prime, RMGBR. That of course I have prepared from the alkyl halide and magnesium. So I have my Grignard reagent. So the nucleophile will be this. So it goes by the mechanism under basic conditions. So nucleophilic attack. We will do this. We will form a tetrahedral intermediate. Here it is. Tetrahedral, because the hybridization here has changed from sp2 to sp3. And now I here have another R group, right? The one that came from the Grignard. And the next step is the loss of flavoring group. So I'm reforming the carbonyl. Chloride is departing. And what I'm saying is that when you do the reaction with anhydrous, it's essentially the same, but your leaving group, instead of being chloride, so this is plus chloride, when you do that with the anhydrous, your leaving group is going to be a carboxylate. So this is O negative, which is also a good leaving group. Not as good as chloride, so that explains a lot about the reactivity, the difference in reactivity. Nonetheless, the reaction goes the same way. But what I want to say here, we know that Grignard reagents also react with aldehydes and ketones. So if you have an excess of Grignard, this is a ketone right here, the product that you just formed. So that will be can be attacking, and you have an excess of the Grignard reagent. You will have the attack by another, say, this is your nucleophile, so say another molecule. And this time, you're going to form an alkoxide. And check out the nature of this alkoxide. You have added one R group here, and you form a ketone. Since you're adding another one, this is now, I'm going to say R prime, tertiary alkoxide, which upon acidic workup, it will give you the tertiary alcohol. So that is, and that will happen also if you do this reaction with anhydrous. Again, the difference is that we have another leaving group. Now, what if you don't want to get the alcohol, but maybe you're interested in isolating the ketone. So for that, we need to be using a different reagent. And that reagent is Gilman. So I'm going to be writing Gilman reagent. Is a cuprate. Gilman, that's an N. All right. So this is, say, I'm going to do ethyl, for example. Diethyl, and the counter ion is lithium, for example. That will be the structure of my Gilman reagent. And here what you will be transferring your nucleophile is the ethyl group with a negative charge, let's say. But Gilman cannot attack ketones. So let's redraw the first step. What would happen if you use Gilman instead of Grignard? So at this step, let's remove this arrow here. We already did the Grignard. So now what you will be doing is transferring this over here. So you're transferring essentially this. And you will form, similarly, a tetrahedral intermediate. because I did that example with ethyl, then I'm going to have ethyl here. Not quite. So I have my tetrahedral intermediate. I was jumping one step. Here you reform the carbonyl group, lots of leaving group. I'm following those steps. And here you're going to get, well, here you have an ethyl because my chosen reagent here, right? So that's a ketone. But Gilman cannot attack ketones. So that's your pathway to getting ketones from either acid, chlorides, or anhydrous. So you want to do the full, say, all the way go to the alcohol, then you use Grignard. Because Grignard, as we had learned before, will attack aldehydes and ketones. But if you just want to stop at the ketone and not go from there, then you would use Gilman reagent. Gilman reagent will also be used. I'm going to later do videos about Michael additions. These are good Michael donors. And Gilman can also be used in SN2 reactions, so as nucleophile in SN2 reaction, which Grignard cannot be used for. All right, so we're going to keep learning on those reactions with other reagents. Here, what I want you to remember is that but the acid chlorides and hydrides, they will undergo the reactions in similar fashion. And we would use, again, Gilman to stop at the ketone.